CLion, a cross-platform IDE for C and C++. Download now.
So welcome to my talk. Thank you all for coming. To me, talking a little bit and ranting a little bit about our journey for changing our standards version from 14 to 20 in Sea of Thieves. My name is Keith Stockdale, and let's get going. A little bit about me. I always like to kick off any talks I'm doing with a picture of myself. So this is going to be a joke. In that the last time I did a bit of public speaking was at my wedding last summer. But yesterday I did a lightning talk, so that's not quite true anymore. But this is the second last time I did a bit of public speaking, and I hope it goes as well as it did then. I'm a senior software engineer at Rare, and I've been at Rare for the last 7 years. But I actually started as an intern back in 2015, so I've been at Rare off and on for the last 10 years. And I work on the rendering and engine teams, so I do a lot of GPU particle simulations, fluid simulations, that sort of thing. And here's some links. I'll flash the slide up again at the very end, just for people that don't have it. But my LinkedIn, GitHub, and then my personal project, which is trying to make a shading testing framework in HLSL, which is DirectX's shading language of choice. Okay, so about Rare then. So Rare is a fantastic place to work. This is actually what we have. So this is one of our barns. It's just out in the middle of the countryside with beautiful scenery all around. And Rare is 40 years old this year, which is quite old for a game studio. It is probably one of the oldest still in existence. And in that time, we have released over 100 titles. Some of those titles might include Donkey Kong Country, GoldenEye, so I know I always went over to friends' houses to play GoldenEye, Banjo-Kazooie, and more recently, Viva Pinata. Now, I wasn't here whenever we were actually making those. I joined Rare whenever we were making Sea of Thieves, which is going to be the topic of discussion for today. Now, alongside Sea of Thieves, we also have Everwild in production, which becomes a little bit important later on. So agenda is, I'm going to talk about Sea of Thieves, what it is, some backstory of the upgrade, so what actually got us there, and then summarize the motivations that actually convinced that this was something we wanted to do. And then a little bit discussion of planning, right? You don't just launch into this work, you want to do a bit of planning beforehand to make sure you're actually doing it correctly. And then the fun part. So we'll actually flick the switches and then see what breaks, and then actually fixing those things. And then once we're all done, we'll have a little bit of a chat on some conclusions and then some discussions about what I want to do from here. So first off, what is Sea of Thieves? It's a game, but more specifically, it's a pirate game. So the whole idea is you get into a crew with your mates or just by yourself and go off into the world and do piratey things. Now, piratey things is quite nebulous. It could be something as simple as going out and finding some buried treasure, digging it up, or it could be just watching other people do it and then stealing their treasure, like the good pirates you are. Or it could be something more mystical, more fantastical, like fighting off a massive megalodon in the middle of the world, right? So there's a wide range of activities here. And for people who are more story-focused, you could do something like teaming up with Captain Jack Sparrow to go off and defeat Davy Jones, right? So huge amount of stuff. And I haven't even touched on even like the starting of what Sea of Thieves is. So we actually have a YouTube channel where we actually explain this. We have a whole playlist on this. So if you want to go and have a look, there it is. I'll leave the QR code up for a little bit of time if you want to take a picture. Yeah, okay. So the beginning. So how did Sea of Thieves start? It started off with Visual Studio 2013. So the actual repository came into being in December of 2014. So we're using C++ 14 with Visual Studio 2013. And we knew that Sea of Thieves was going to be a live service game. So we weren't just going to release it and that'll be it. This was going to be a game that we were going to be continually evolving over time. So right from the get-go, we had a massive culture change at Rare. And we heavily invested into continuous delivery, continuous integration, automated testing. And if you've ever seen talks from us, chances are it was about automated testing, especially if it was a software engineering one. So we've done talks at GDC and at Unreal Fest, and I even gave a talk last year at GDC about unit testing shooter code. And one other thing that you have to know about the start of Sea of Thieves is that it is an Unreal Engine game. And we started off with Unreal Engine 4.6, so this was fairly new, fairly raw Unreal 4. And we kept taking new versions until 4.10. Now 4.10 actually came out, I think it was 2016. So the question there might be, why did you stop taking new releases? And what it really comes down to is there are many, many engine mods, about 37,500 to be exact. So these could range from single line changes all the way up to, we are taking this file now. This file is now ours. And the reason we had to do this was to support big features that we need in our game that did not exist in Unreal. Things like our water, which is pretty important for a pirate game. So this was something that we couldn't just build on top of the engine. This had to be interleaved throughout the renderer. Other examples might be our GPU particle system. So Unreal Engine did have some support for GPU particles, but not the support that we needed. So this, again, is something we heavily modified in the engine. And there's modification throughout. It's not just on the rendering side. It's all throughout the place. And what this basically meant was that each release that we took more and more time to integrate, right? So you take it in and then you try to coalesce all the changes that Epic have made versus ours and try to make it work and not break things. So this became quite unmanageable. So essentially, we forked, right? So we just went off in our own way, and Epic went off on their own path. But we did cherry pick some features when it made sense. So if Epic came out with something really cool and we found it to be quite easy to take back, we did, right? So there's a bit of pragmatism there. We just weren't going to be taking any full new engine versions. And that works. Development continued, and we released back in March 2018. So this is actually our 7th anniversary. So Sea of Thieves has been going quite a while. This is a picture of me whenever the game released. This was my first game and I was very excited. So as soon as I saw it in stores, I had to take a picture. But as I said, we are a live service game. We did not stop in March of 2018. We continued to release more and more great new stuff, like fishing, harpoon launching, and then we also developed the lore of Sea of Thieves with more story. So this is taken from our tall tale called The Wild Rose. And we also collaborated with other IPs. So I mentioned that we have a whole campaign around Captain Jack Sparrow and the Pirates of the Caribbean. So yeah, that's where that all came from. Now, while we were developing, obviously Epic is off developing as well. So in April of 2022, they released Unreal Engine 5.0, so a major upgrade. And this came with big features like Nanite and Lumen. If you've never heard those terms, essentially these are big new graphical powerhouse things that make your games look great. But also something that I'm more interested in came with C++17. Yes, it did take them about 4 or 5 years to go from 14 to 17, but they still did it. And that got us really interested. So we made a task to upgrade as well. So we made a task, and then we just leave it there, hoping we could prioritize it at some point. But then time went on, and we weren't able to. And UE 5.3 is released about 1.5 years later, in September of 2023, and it comes with C++20. So they did it really quick. Going from 17 to 20, they did it in about 1.5 years. Again, we're getting a bit jealous, so we also want to upgrade. You might be asking, but why? Why? And it really just comes down to improved developer experience, right? We want all the nice new things. We want stuff like structured bindings. We want stuff like CTAD. We want stuff like concepts, stuff that actually makes VNA usable for most engineers, and designated initializers. So all of this stuff is great. And then also Everwild is also on C++20 because it's using the latest Unreal Engine. So we've got developers working on both projects, and people are very happy whenever they're able to use all the nice new features of 20, and then they have to come back to Sea of Thieves, and it's not very nice going back to 14. And then also you get better compiler support and improved warnings, better optimizations, all of that good stuff, right? But there's a problem. And I'm going to illustrate this problem with a line of priorities. So right at the top here, we have P0s. So these are the things that are your showstoppers. These are the things that are heavily impacting player experience right now. So our players are not happy. So these are things like server crashes. Nobody wants those. These are things like investigating exploits. Nobody likes cheaters. So whenever these types of things come up, you drop what you're doing and you go and fix it, right? Then you have P1s. So these are more run-of-the-mill, we're making a new game feature or perhaps fixing a visual bug. These are the things that are coming out in the next planned releases, right? These are well understood features that we're trying to develop. Then you might have something like P2, which are things that are going off in the background. So improving editor load times, improving client performance. So these are all things that are always beetling along in the background, but don't really have any set deadline. And then right at the very end, I have a section called Never Going to Happen. And this is where upgrading to C++20 languish, unfortunately. And the reason for that is it's just really hard to prioritize. C++14 is fine. We shipped on it, we developed on it, we were working with it for 10 years. It did the job. And it doesn't directly improve player experience, right? We're not going to put an upgrade to C++20 on our change notes, right? Players don't really care. But the thing is, I say doesn't directly, but it does indirectly, because anything that improves developer experience will indirectly improve player experience as well. We had some libraries that didn't support 17 or 20. Anybody worked with WinRT? Yep. So that was out. We had to actually find some substitutions before we'd even start. So that was also very hard. And also, it's hard to gauge the amount of work required, right? There's no real way of gauging how much work would have to be involved. So just to illustrate that, let's have a little discussion about the size of Sea of Thieves' codebase. So just the project itself, so this is on top of the engine. This is what our game developers are writing. We have about 28,000 files for C++ files only. We've got other tooling, but just C++ is about 28,000. And that amounts to about 3 million lines of code. Now, we've got a sizable amount of stuff in the engine as well. So it's about 19,500 files, and about 3.5 odd million lines of code. So we're talking about 6.5 million lines of code that between us and Epic have wrote. And then I mentioned that we've got a load of engine mods. So we have this little engine test project off on the side, so we can actually write unit tests and integration tests just for our engine mods. So it's a bit smaller, at about 580 C++ files, about 56,000 lines of code. Now, in any Unreal Engine, this is not, any Unreal Engine project, this is not the totality of your lines of code. Unreal Engine generates a huge amount for you due to its reflection system. So I actually looked to see how much that was in just Sea of Thieves by itself. And about 2 hours later, I got a result of about 29 million. So it's a huge amount of code. Now, obviously, we're not writing that 29 million. The stuff that we've wrote is more like 3, 4 million. So how much of that would we have to change? We didn't know. So again, hard to prioritize. But then 2 big things happened. The first thing is we launched Season 11. And that was just like any other update, except it came with a big thing, which was our GDK upgrade. And what the GDK upgrade meant was that we'd thrown out all of our old Xbox development kit stuff and swapped it in for all the nice new Xbox GDK stuff. So out goes all of our libraries that could not be upgraded. So we have now unlocked the potential to actually going to 20. So that was a big thing. So we can actually do it. We just now need a little bit of a push to get there. Then we launched on PS5. Now, we've been an Xbox game studio for the last 20 odd years. We're very good at making Xbox games. We have never, up until this point, made something for PlayStation. And this was really exciting for us because it meant a whole lot of new toys. We got nice new dev kits, nice new infrastructure, nice new everything. And one of the other things that we got was a nice new compiler. So one of the first things you want to do whenever you're going to port is get the thing to compile. And we started to see stuff like this. So because we're in MSVC, we're using MSVC macros, such as this, zero memory. This was just fine, it worked everywhere. But of course, this was not going to work with the PS5 compiler because it does not know what this macro is. So we have 2 options here. We do more of a standard thing, or we do what we did do, which is a bit of pre-processing branching. And the reason for that... Sorry, I'm just hearing Guy sigh. So why, you might ask? Why not just fix the code? Well, let's just weigh up things, right? So the pros for fixing the code, you get minimal tech debt, right? You just fix it right then and there. A few cons, though. You could break other platforms. You're changing code for all platforms if you're doing this, which meant that you would have to validate it for all other platforms, which would slow down the port. We needed to get this out. We wanted to get to the point where we could actually fix things and actually getting working properly and optimizing things for PS5. Now, contrast that with pre-processing branching. So the pros are there's much less risk because you're not actually changing the code of the other platform. You're just changing the code where you need it for PS5, which meant you could move much faster. You didn't have to do as much validation. There was much less risk. But of course, this comes with the problem of accruing tech debt. And if anybody in this room was in Peter's talk just before mine, he talks a lot about this. But the nice thing is, we knew we were doing this. This was a calculated decision. We planned this. We knew this was going to happen. So it went up on our board under sustainability, and we were tracking it the whole way. So this was not something that we were doing and hiding, right? So compiler-specific macros are one thing, but then other kinds of issues arise. So take this kind of code here. The astute among you might think this was not compiled, but this is compiled for 10 years for us. The reason this will not compile is because ret type up there, that's a dependent name. So you have to actually put in type name here to tell the compiler this is not an expression, this is a type, right? So that's a dependent name. We need type name to tell that. Why? Why are we seeing this now? Why would the compiler not tell us this until we went to PS5? And that's because a little thing called permissive with MSVC. I heard sighs in the room. That's a good expression. That was a nice reaction. So this is the default for C++ 14 and 17. And as I said, we started this project all the way back in 2014. Permissive was the only way forward. That was all we had, right? And what it effectively means is non-standard conformance C++. This is essentially Microsoft C++, right? And the whole idea is that it allows you to get away with more stuff. It's nicer to you, right? Nicer. And it's turned off with permissive minus, as in it's taken away the permissiveness of it. And the nice thing is the MSVC team have been moving more towards standards conformance. So 17 was the last where it was defaulted. And permissive minus is now the default for C++20. So if you flick the C++20 switch, you also get permissive minus. And there's a whole history around this, and there's a lot of interesting things that come up whenever you start playing around with permissive versus not permissive. So here's some links to the MSVC blog post about this. It's pretty interesting. So these are the two, I'm going to show you two examples now that motivated me to actually start doing something about this. So nested lambdas. So say we have a struct, and it has a single bool in it, so it's of size 1. It's a member function called do, and inside that member function, we return an immediately invoked lambda expression. And we capture the this pointer. And then we do another one, right? And we capture the this pointer again, and all we want to do is return the size of the object that's pointed to by the this. Now, and then we print it out. Now, in every sane compiler that is standards conformant, this will return 1. It'll print out 1, right? Because A is of size 1. But if you do this with permissive mode, you get an answer of 8. So both these compile just fine, both on MSVC and the PS5 compiler, but you get very different results. This is scary. This is differing behavior. And the reason for this is because in the inner lambda, that this is not pointing to the thing that was captured outside. It's pointing to the outer lambda, that object itself. Because the outer lambda has captured the this pointer, it's of size 8, right? And pointers are 8 bytes in size. So this is scary. There's a problem. And this was the killer example that got me properly going to do this. Another good example, another good reason for getting rid of permissiveness is copulation. So say we have one of these structs, and all it does in one of its special member functions, it just increments a global. So if you copy one, construct one, destruct one, move one, we're incrementing this global number. So if we take that and go into a main function, and we just create a lambda, and all we do inside this lambda is create one of these structs and return it. And then we call this lambda and assign it, and then print out number. Now, thanks to the nicety of copulation, this should only print out 1. And that's what you get with standard. Great. With permissive C++, you get 3. And that is because you construct one, and then you return it out of the function, so that's 2. And then the lambda ends, so you get the destructor there. You don't get copulation until you turn on optimizations with permissive mode. It treats copulation as an optimization, and technically maybe it is, but it changes behavior, which is a problem. So all of this is to say, permissive minus is important. Permissive C++ was detrimental to our developer experience. Horrific. I think this is a bare minimum. Compilers should interpret code in the same way, right? You chuck the same code at 2 different compilers. They should behave in the same way. And more copulation is obviously great. Right? So bringing back our line of priorities again, this sits firmly at P2. This is something we can absolutely prioritize. I can definitely convince people this is a good thing to do. Now, this also allowed us to reprioritize C++20 somewhat, right? Because turning on permissive minus should help towards 20 because it's the default for 20. It also means that because this is work we have to do, we absolutely have to do this, it'll give us an idea of like how much code would changing one of these switches actually touch, right? We've got millions of lines of code in Sea of Thieves. Are we going to be touching millions, thousands, tens of thousands, maybe hundreds, right? So it's going to give us some benchmark there. And it's largely the same kind of work. So you flick a switch, hit compile, fix some compilation errors, rinse and repeat. Same sort of thing, right? Now, I mentioned that I did this. So this was a project that I undertook myself. So why me? Why would I do such a thing? Well, number one, I thought it'd be a great learning experience. And I would be doing this in my learning time. So I did this in Friday afternoons. It was not something that was tabled up. It was not one of my priorities, although secretly it was. And also selfishly, I want all the new features, right? I want the improved developer experience. I want Sea of Thieves, because it's a live service, it's an ever-changing game. I want to be maintaining it, keeping it sustainable. And I've done similar things in Sea of Thieves before. And I want to talk about that because it becomes quite relevant. So consider a bug that tests can't reasonably catch. You can do this, but not reasonably. So this happened back in 2021, and it involved a vector, or in Unreal Land, a T-array, but I've just made it standardified for this. So you have a vector of load requests. These are in-flight async load requests. So whenever you kick off an async load, you put it onto this vector, and whenever the load completes, this completion handler is invoked. And the whole idea here is, in the completion handler, we would just go through our in-flight requests and then remove them because they've been completed. Now, this code was unit tested before I show any more. It was well unit tested. It did the thing we wanted to do. Now, the predicate that we passed to remove if here looks like this. And again, this does the thing. It does the right thing. But this was causing huge issues on our servers, to the point where sometimes it would cause hitching so bad that people were getting disconnected. Very bad for player experience. So we all jumped on this. There's a P0 very easily. And we were able to solve it within 3 hours. The problem is, if you haven't caught it, we're missing a character. We're missing an ampersand. So we're taking an async load request here by value. And this is a problem whenever you've got a lot of in-flight load requests. It's an even bigger problem whenever a load request looks like this. It's just a vector of strings, right? So it is just exceptionally slow, right? So we had tested this. It was well tested. We were able to solve the problem really quickly, 3 hours. Very good. I wasn't satisfied because this could happen again. So I came up with a solution. And what the solution was, it was a type trait. And I very verbosely called it func args are all ref or pointer or small trivial. And my definition of small trivial is trivially copyable, 16 bytes or fewer. And the whole idea is you give it a callable along with the argument types, and it will tell you if that callable takes its arguments by ref, pointer, or small trivial copy. And then, because we're good engineers, we write unit tests just to make sure it works. And because it is a type trait, we don't need a whole testing framework. We just need static assert. You don't need to read this. You just need to know that we've got a huge amount of static asserts to cover this. And one other nice thing about static assert is you can give it a lovely error message, right? So it's not good enough just to error, right? If some per person comes along and does the bad thing, they don't know what went wrong there, really. So providing a nice error message which tells them what they did wrong, a rationale behind it, and then also the way to fix it is a very good thing for developer experience. It's something we should be striving for with error messages. So we have all this. We've got well tested. We've got our error message. And so we just go and apply it everywhere, really. So all of our algorithms, like find last by predicate, remove all, sort, a huge amount. And we hit compile. And does it compile? No, because this was not the first time this had happened. This was not the first time an ampersand had not been caught during code review. There was a lot. It found a lot of issues. So the whole idea is I had to go and fix up all those places, and then you submit the actual static asserts, and then this problem can never happen again. That's the whole idea. So I maintain flicking permissive minus and doing this kind of work kind of the same thing. The whole idea is you are flicking a switch, fixing everything that's broken, found to be broken by that switch, and then never letting those things happen again. Right. So plan of action. This is background work. Sea of Thieves is a game, as I will reiterate again, and new features and perf work unfortunately take priority. Right, absolutely. The nice thing is, because Sea of Thieves is a game, no real deadline. This is not going to go on some changelog. This is not going to go on any release notes. Players do not care. So that's quite nice. And one other thing to mention, small changes. So the whole idea here is we're not going to get all the fixes plus the switch all in one change list and submit it all as one thing. We should be dividing fixes into small change lists for two reasons. Number one, it's easier to review. Nobody wants to see a code review with 300 lines of code changed. That is what gets apathy. That's what people just like take, just their eyes glaze over and then hit accept. You don't get a good code review that way. So you want to make sure it's small and like it's fair to the reviewer, right? And also it's easier to undo if something breaks. So if I accidentally break something while I'm doing this here, it's easier to roll it back rather than having to roll back a whole big change. Enabling the compiler switch should be the last thing you do. It should be a one-line change that comes in after all the fixes. Okay, so step one, standards conformance. That's the best bang for buck. And we just want to see these two compilers shake hands, say the same code, and say they do the same thing. Step two, C++ 17. It's a nice middle ground between 14 and 20, I think. And you get nice new things like structured bindings, ctad, if const expr. Fantastic stuff. And then we go on to the final bit of C++ 20, where we get even more nice stuff, like concepts, designated initializers, and spaceships, right? So there's the plan. And I've spent the last 40 minutes talking about the plan, so let's actually get to the fun bit. And the fun begins with a little thing called two-phase name lookup. That also got a good reaction, okay. Who here in the room has come up with this, has come against this before? Yep, okay, cool. So what two-phase name lookup comes in, it means is it's effectively the rules for name resolution in templates. And surprise, surprise, permissive C++ does not follow these rules. And they do a thing that I'm going to call single-phase name lookup. So two-phase name lookup is whenever you have a template and you have something in that template that does not depend on any of the template parameters, it can evaluate those expressions and validate them at definition time. But if something depends on the template arguments, then it has to delay that evaluation until instantiation time because you can't evaluate it until you actually know the type. In permissive C++, it's only evaluated at instantiation time. And what that means is this code will compile in permissive C++, because we never called do thing. It's never called, therefore it's never evaluated. It's never parsed at all. So that's a fun thing. Another good link by the MSVC team about all of this here. It all comes down to how templates were originally implemented back in the 90s. Some compilers went one way, other compilers went another way. It was standardized to mean one way, and MSVC sort of took the wrong option the first time. But yeah. Great history here, and we're actually moving more towards standards conformance with MSVC. So one of the first things that come up with this is accessing templated base class members. So say you have a templated base and then a templated derived class, and in that templated derived class we have a member function that tries to call the base class's member function. Now this will not compile in standard C++, because there's nothing in that call to do the thing that mentions T. So this template can be, at least to the compiler's knowledge, evaluated at definition time. But of course, do the thing doesn't exist until base T has been instantiated. So you will get a compiler error. So what you have to do is usually make do the thing be dependent on T by dereferencing the this pointer. Because to dereference the this pointer means you have to know what the type of that class is, and to know that, you must know what T is. So this will delay evaluation until instantiation. This goes the same for type aliases as well. So same sort of thing, we have a templated base with a type alias, and in the derived, we try to use that type alias. We don't have the luxury of just dereferencing this pointer, so we have to usually do something like this, where we just get a type alias by referring to the base type using type name here. So we're actually involving T in the definition here. Now, this gets us on to templating the things. So say we have a template struct here, and in that template struct, we have a function template. So it doesn't depend on the outer struct's template type. And we want to call this static member function from outside the context of other here. If you try to write this in any standards conforming compiler, you'll get a compiler error. And it'll look something like this. And it might throw you through some confusion. So it's talking about, it's expecting an expression, it's expecting a semicolon, it's saying it wasn't expecting the closing angle bracket. What's going on here? Well, the compiler doesn't know that do the thing is a template. Anything after that initial scope is perceived to be an expression. So it's thinking that do the thing is a name, and that we are actually doing a less than operation here. So we're trying to do the thing less than the type T, which makes absolutely no sense, hence the terrible error message. So what you have to do is you have to tell the compiler that do the thing is in fact a function template. So if you ever come across this odd syntax, colon, template, that's the reason why. It's because you have to tell it this is in fact a template. Now I have to get my tenses correct for this one. So static assert false. This is quite a common thing to want to do. So say you have a template and you want it to only be valid for certain instantiations. So in this case, it's only valid for ints. And the way that we're going to ensure that's the case is we put a static assert false in here. And this worked just fine for us in Sea of Thieves, but this is not standards conformant because there is nothing in that static assert that depends on T. So it is evaluated at definition time. So what you get here is a program that will never ever compile. It is ill-formed, no diagnostic required. So what people have to do is make sure that that condition, that false, is dependent on the type T. And what people typically do is to make a variable template. Like this, we call it T is always false. Everybody does the same sort of thing where you make it dependent on T. Now, this was the case. But then enter P2593 by Mr. Barry Revson, who decided this was stupid. And I agree, it is stupid. The whole idea is this is ill-formed and it shouldn't be. It should be made well-formed. And as of GCC 13, Clang 17, and MSV 19.40, this has been fixed for all versions from 11 onwards. So whenever I was doing this work to upgrade to permissive minus, we were on 19.38, I think. So I just missed it. So I did have to change a lot of things to T is always false. But this is now fixed. You can write static assert false now. Happy days. Okay, so non-const string literals. This makes no sense because a string literal is typically going to be stored in a read-only section of your executable. So having a non-const char star to it makes no sense because it implies that you could modify that data. Permissive C++ let us away with this, and this is one of the biggest offenders. We had a huge amount of this. So it's a very easy fix. You just put const on it, very simple. So that's pretty simple, but what about const expr string literals? Const expr implies const, right? Ish. So const expr isn't actually a type specifier. It is what is called a non-type specifier. So what this is actually defining is a const expr pointer to a non-const char. So we just fixed it the same way. You can either make a const expr const or const char star. Now, a lot of people in this room might be laughing, just saying, but you should just be east const, but const expr west. So there was a great talk by Dan Sachs on this at Codebase 2018, explaining all of the niceties around this. Links if you want it, but yeah, fantastic talk. And since I mentioned Dan Sachs, and I'm talking about convincing ourselves that doing this upgrade is a good idea, Dan has another great talk from CVPCon 2016, and this is one of my favorite talks of all time. Talking to C programmers about C++, and it's basically solving the hardest problem in software engineering people, right? It's the whole idea is convincing people that what you want to do is the correct way. So if you want to do this sort of thing and you're finding it hard to convince people, that's a good talk to watch. Okay, implicit conversions. Jason, avert your eyes. So, so in Sea of Thieves, everything I'm about to show you did compile. But obviously the PS5 compiler found it for us. First thing, implicit conversion from false to null pointer. You'll be glad to know that there was no implicit conversion from true to something that is valid, which is nice. So C++11 gave us this nice new thing called enum class, which the whole idea was to make sure there was fewer implicit conversions between enums and integers, which is great. And it worked in most cases for us, except we could do things like this. So we could define the actual size of a pointer, sorry, size of an array using an enumeration. Thankfully, it doesn't work the other way. We had to do the static cast, so that's good. That was a win. But it didn't work the other way around. You could implicitly cast from an int back to an enumeration very handily. So there's a fair amount of this in Sea of Thieves to fix up, very innocuous, but yes. And then there was slight differences between direct versus copy initialization. So say we have an A, and then we have a B which can be converted from an A, and then we have a C which can be converted from a B. This would compile just fine in Sea of Thieves beforehand. It saw assignment, well, copy initialization as the same as direct, but there are subtle differences in overload resolution in the language. That means you can't do this. So the fix is simply to use direct initialization, and then this conversion chain will actually work. Member access. The whole idea here is we're just going to try and assert that the type of our member here is an int. That's the whole point. And this works just fine because my member is public. What if you do that? This would compile in Sea of Thieves before with permissive mode, which is bonkers because it completely throws away encapsulation. And it's even more bonkers because we depended on this for one of our testing frameworks. Because in Unreal Engine, you have properties, and properties can be public or private, and you can access properties quite easily just by using its name. So the idea is we could get properties via their name and you'd know the type. So the only fix that we could do here, there was no fix. You just had to know what the private member name was. So there wasn't a satisfying fix for this. We just sort of coded ourselves into a hole there. Don't do that. Now after all of this, thankfully, it all compiles. And if you've never worked with Unreal Engine, this is what you get whenever you first boot up an empty project, or any project really. You get the default map with nothing in it. So it all compiles. We're done, right? No, we're good engineers. We have tests. I mentioned before, we heavily invested into testing, and it's part of our culture. It is something that you are doing all the time. So whenever we run our tests against this, unfortunately, we are getting failures. So what gives? It's something I'm going to call template name lookup. So say you have something like this. So it is a function template that takes in 2 arguments of 2 different types, and it returns 0. And then we have a function template that calls that with a float as the second argument, and whatever t is as the first. And then we have an overload defined after that call. And the overload takes as its first parameter an int and returns 1. Now, does anybody know what this will return in standard C++? We'll say standard, okay. Any guesses what this will return? I heard a very weak 0. In standard conformance, yes, this will return 0. But with Sea of Thieves before, this would return 1, because templates are only instantiated are only evaluated at instantiation time. So it knew the whole overload set at instantiation time, so we would get 1. So both of these will compile with both permissive C++ and non-permissive. Again, scary. This is why it was only caught by tests, right? So what's happening here is something in our lookup rules. The thing that's valid here is the first bullet point about non-ADL. We're not using argument-dependent lookup here. So non-ADL lookup examines the function declarations with external linkage that are visible from the definition context. So whenever I was looking this up, I thought it sounded a bit familiar, and it was. So Matush Push, he had a Back to Basics talk at CWPCon 2022 on this, and in fact he had the same slide, and he talks for a whole hour about the nice vagaries and the nice intricacies of name lookup and overload resolution. So what about now? Once we've fixed that, we're all green. It's all working. Fantastic. We can submit. And the nice thing is it never came out. Our tests found everything. So I just want to take this moment to mention we should all be writing tests. It will save you down the line. So with all that out of the way, we can now move on to the next fun bit, C++ 17. And the first issue we come across is auto pointer. Fantastic auto pointer. Now, for anybody in this room who does not remember what auto pointer is, it's effectively the standard's first smart pointer, I'm going to say. It's effectively a unique pointer without move semantics. So if we have this function here, it will print out hello ACCU because it constructs a log all, and then it destructs before main exits because it's a smart pointer and calls the destructor on exit and prints by ACCU. So we had this in one of our third-party libraries that was used for assertions in our testing framework. So the fix here was simply to upgrade from version 1.0.2 to 5. So this is a framework that we've had like since day dot, probably 2014, 2015 maybe. And the nice thing was it was a really easy upgrade. It was essentially copy and maybe fix 3 or 4 compilation errors. Really easy to do. So that got rid of auto pointer for us. Now on to the next thing, incrementing bools. This was valid. And this isn't even a permissive thing. This was valid C++, standard C++ until 17. It was actually deprecated ages ago though. I think it was deprecated in 98, something like that. But then it was removed in 17, you can't do the same. So obvious fix, don't do the silly thing. And the nice thing is, that was it. That's all we had to do for C++ 17. Super easy upgrade. But again, we're not done. We have tests. And they did fail. We had a couple of failures. So the primary reason for our test failures was something I'm going to call expression order fun. And if you were in Bryce's talk yesterday about the execution model of C++, this is actually quite applicable. So given this, what will be printed out in C++ 14? So the idea is we're getting the size of the map and also and creating an element at element 0 because the index operator actually adds elements. So what will be printed out here for us was 0. But in 17, thanks to P0145, this expression order is well defined. Before it was some compilers could actually do things differently with different optimization levels and stuff like that. But in 17, this was made well defined, and it was made to be 1. So in 14, you were getting 0. In 17, we were getting 1. So the simple thing to fix here is just to get the size first, right, and then just push it back. So just make it very obvious about the order of operations. So be very clear about the happens before relationship there. Okay, and that's about it. So how about now? All our tests are going green, and we submit. And again, never came out. So again, showing the strengths of automated testing there. So now we can get on to the big one. This is where all the fun stuff happens. So what even is C++ 20? So we stopped taking Unreal versions in 2016. And at that time, Unreal's build tool, so it uses a completely different build system from anything else. It uses its own. And at that time, it didn't know what 20 was. It just had 17, then latest. Now, at the time at this point, latest basically means kind of 23. Not quite 23 yet, but kind of 23. So what we had to do was add an entry here for C++ 20 and then pipe that throughout the build tool to actually turn on the C++ 20 switch. So before we even started, we couldn't even flick the switch. So the first thing we came across was aggregate initialization. So say you have a struct like this. So it's got a default constructor. You default it, yes, but you are still defining it. And then every member is public. You could actually aggregate initialize this despite the presence of that default constructor. And then P1008 came along and made aggregate initialization a bit more strict, a bit more straightforward, tied up some loopholes. So basically the idea here is you either write better constructors or just get rid of your default constructor. That's what we ended up doing. Just get rid of the default constructor, use aggregate initialization, be happy. Now, non-const comparison operators. This would compile just fine in 17. In 20, this won't, if you're on MSVC. Everywhere else you get a warning. But of course, we all compile with errors as warnings, right? So it's still an error. So the error that you get here for MSVC is this. So overloaded functions have similar conversions. Now that implies I wrote 2 functions. I didn't. I'm very confused. And then it goes on to say that on the next two lines is that you have two operations that do the same thing. Oh, yes, do the same thing. I'm just like, well, these are the same. And then it says synthesized expression y is equal to x. Okay, so the compiler is synthesizing something for us. I'm very confused at this point, so I go to another compiler to see what it says. So I go to GCC, and it says this. So it says warning, so it's a warning, it's not an error. These are ambiguous. So again, it's alluding to the fact that there are two, even though I wrote one, and that the second is reversed. Okay, so that might have something to do with the y is equal to x thing. And then in the next two lines are basically the same thing as what MSVC was giving us, but GCC does one very nice thing. It tells me how to fix the problem. It says, try making the operator const. Okay, so go back and do that, and everything's fine. It's fixed now. Now, obviously it makes sense, this should be const, but I'm just sitting there wondering, why? And unfortunately, this is where cpref failed me. I had to dive into the standard to figure out why, and it all comes down to the spaceship operator. Specifically, this bullet point. So for relational and equality operators, a synthesized candidate is added to the candidate set when the order of the two parameters is reversed. So there's where the y is equal to x is coming from as well. So that's why. So we've got a const and a non-const parameter, and then we've got a non-const parameter and a const parameter. And obviously the call to those that's ambiguous, and that's where we're getting the errors from. So that was a fun one. So we can thank the spaceship operator for that. You will never write another non-const member function that is an equality operator. This was good for us. So if you print this out, so this actually compiles in C++17. Any idea what this prints out? I'll give you a clue. It does not print out the hello ACCU. Yeah, it takes the void pointer overload. It will print out the pointer address. Now, we had a lot of this because in Unreal Engine, every string is a wide string because Windows. And whenever we wanted to pretty print types, objects of different types in our assertion error messages, we would overload the OStream operators and our testing framework would print it out. So obviously, whenever we were pretty printing things, we weren't actually writing tests that were failing in some cases, so we didn't actually see this, right? So the nice thing is, in C++20, these are deleted. So we got equals delete on these. You can't do this anymore. This will not compile, which is great. And it also meant that I was able to find and fix up some of our testing frameworks. We actually got pretty printed assertion messages now, which is great. So that is C++20 improving our testing framework. So that's a good thing. And then the next thing is result of to invoke result. So result of was deprecated in favor of invoke result in 17 and then removed in 20. So say you have something like this, so you have a callable, it takes an int and a float and returns a bool, and we just want to make sure that that is the case. So in this case, all you have to do is simply swap out result of for invoke result, and everything is good. Nothing too interesting there. At that point, we're compiling. But of course, we've been here before, so we try our tests, and something interesting happens. Everything's green. There's no behavioral changes there whatsoever. It all just worked. And we submitted it, still no issues. Upgrade done, right? Not really. Because one of the things that C++20 does is it deprecates a lot of bad behavior, a lot of bad use of things. So I didn't like that idea. I didn't like our engineers being spammed with warning messages whenever they were building. So I didn't quite submit it at that point. I wanted to fix all the errors first, all the warnings first. So the first is comparing arrays. If you have these two arrays, they both contain 1, 2, 3, what will be returned from this function? Will it be 1 or will it be 2? The answer is 2. This will never return 1 because you can't compare arrays. This will decay into pointers and you're comparing memory addresses. Two objects can't be at the same place at one time. You'll always get false. We have this in Sea of Thieves. I say have, I don't say had, because to fix this is to change behavior. And I am not in the business of changing behavior because that's where you get it. That's where you fall foul of Hiram's law. So instead, I just make it very clear that we are comparing memory addresses here. But we don't leave it there because we're good engineers. We task it up. So we make it very clear that we know of this tech debt now. So again, C++20 is showing us where our tech debt is. This was unknown tech debt to us now. It is now known. And it's something we have to come back and see if it's something we want to fix, if it will change behavior. So that is something, that's a to-do. Enum implicit conversions then. Say you have these unscoped enums, so it's like C-style enums. You have first, second in the first one, third, fourth in the second. This is perfectly fine to do. You can add them. But in C++20, this is deprecated. You get a warning here. So the initial thing that you might want to do is just static cast, right? But the thing is, where we were using this most was just to write compile time constants in a really shorthand way without writing static const expert, yada, yada. And that worked, essentially. But that just means that we should be doing the right thing here. We should just change these definitions into const expert things. And then we can treat them like ints because they are ints. They are not enumerations. It was just using enumeration syntax for convenience. Volatile equals thread safe, right? I find a lot of this, especially in lock-free queues, where we were expecting volatile things to be atomic and thread safe. Not so. So a lot of the uses of volatile that would imply that the developer thought this has been deprecated, which is great. Now, obviously, I'm not going to fix this because changing this would definitely be a behavior thing, and I'm not touching race conditions with the barge pull. So I've just made it more obvious that we are not doing an atomic operation here. And of course, adding a task. We are not forgetting about these things. This is tech debt that we now know of that was previously unknown. And there's a...
I'm curious why it would not have been a nuance to change it to atomic yet. I mean, why were you sure that it would change behavior?
I wasn't sure.
Oh, okay.
And I was not going to... I was out of scope. I'm not going to... So the whole thing was, why was I not sure? It's because the whole operation here is just to upgrade to 20. I am not in the business of changing behavior or even attempting or even considering it. If something even looked like I'd be changing behavior, I was not doing it. This is something tasked up. It currently works, and I'm not going to take the risk. It is too risky. So there's a great talk on this by Ben Sachs at last year's CPPCon, all about volatile, what it's used for, what it shouldn't be used for, and this is a slide along with atomics as well. So if you want to learn more about that, great talk to go to. And then we get on to capturing this with the default value capture. So say we have a struct, we have two member functions. In the second member function, we want to call the first member function in a lambda, and we capture this by the equals. This will now give you a deprecation warning. This has been deprecated in 20. And the reasoning for this, given in the paper, is because in C++17, we got the ability to capture the object pointed to by this explicitly in the capture list. So it was deemed to be ambiguous as to whether you meant to capture this pointer here or capture the object pointed to by this. Now, whenever I first came across this, I thought that was silly. It's a pointer. If I capture an int pointer, I don't expect it to dereference it. But if you read through the paper a bit more, you get more into the wording of the standard and what this pointer is and is not. So it does make more sense the more you read into it, because this pointer came before references. If it probably has more reference semantics than this, and especially whenever you go back and look at our non-const comparison operator example, it wasn't getting confused by a pointer and a reference. It was getting confused by two references, right? So this is a problematic one for us. This was littered everywhere in our code, everywhere, because we're a network game. And we're making a lot of continuations, a lot of stuff like that there. We're capturing this pointer with the default equals everywhere. This was the largest amount of change involved. And unfortunately, the fix to this is this. And the problem with this was only brought in with C++20. This is only valid syntax in C++20. And I'm doing all these fixes in 17. So I didn't have this at my disposal. And so the only thing left to me was just to explicitly capture everything in scope. So I had to go around everywhere to do that, to get rid of this warning in a way that was satisfying to me. But the nice thing is, once I did that, we're done. We're happy days. Yes?
On your prior slide, did you consider a macro rather than capturing throughout?
I did, and I said no.
Is it? Okay.
I refuse.
Okay.
Yeah, so we're done. Now, we can talk about some conclusions from this. So just to remind everybody, this is what the code base looks like, about 6.5 million lines of code-ish. So some upgrade statistics then. So for permissive minus, the number of files that I changed or added, about 215. So pretty small, to be honest. And the number of individual changes, so these would be your diffs, right? About 369. And I separated that into about 30 change lists that I got independently reviewed by a huge amount of the dev team. And the number of tests that were failing that I had to fix the behavior for were 6. Now, compare that with 17. There's only 68 files changed or added, and with only 31 actual diffs. The majority of those 68 was just me upgrading to the new assertion library from up to version 5 to get rid of the auto pointer. And that only took 4 change lists, and 2 tests were failing. Now, 20 was a bit of a leg up from 17, so we're up to 111, with 408 individual changes, where the majority of those was the capture, unfortunately. And that was separated over 18 change lists and no test to fix, which was great. So we come to the question, so how hard was it, in my estimation? Now, initially, I had a line here with, a column here where I just gave a number out of 10, but on review, I think I was just pulling numbers out of thin air. So I'll let you decide. So time to first successful compilation. This does not factor in the time it took me to fix tests or to get rid of warnings. This is just the point of, I flick a switch to the point of me getting to the editor. For enabling permissive minus, about 2 dev days. So we're talking about 4 of my Friday afternoons. The actual time to submit, though, was about 4 months. And that's mainly down to, well, we had other priorities. It was just me. A lot of other things to be going on. Some of those behavioral changes that were found by the tests were hard to track down. So there's a huge amount that goes into this. So it's very easy to get a proof of concept to prove that it can be done, but to actually land it and deliver it and say that it's done, harder, right? So it took me about 4 months there. Contrast that with going to 14 to 17, about 3 or 4 hours. It took me an afternoon. It's pretty easy. Most of that was just upgrading our library, getting rid of that auto pointer. It only took about 2 weeks to submit. So we were only on permissive C++ 14 for about 2 weeks before we went to 17, which was pretty great. So that was nice. 20, bit of a leg up again, about a day of dev time, maybe 2 or 3 Friday afternoons. And time to submit was about 3 months. Again, same sort of thing. We've got priorities. The studio, I didn't want to impede on other big releases, so I was delaying things for certain releases. So yeah, about 3 months. Now, people are always concerned about build times, never flicking switches like this. So these are my specs. So it's a pretty beefy PC, 32 core, 128 gig of RAM. And we are using MSVC 19.42 here. And we are using development editor. So for people that haven't actually built Unreal Engine before, this is the default, essentially. This will give you some optimizations. I think it's 01, not entirely sure, but it doesn't give you full optimizations. And it is the default way of compiling the editor. So, and also, one thing to mention here, you'll notice there isn't a column here for 14. And the reason for that is because there is no point in Sea of Thieves' history that compiles for all 3 standards. 17 got rid of auto pointer, 20 got rid of result of. So those are breaking changes. So I can compare 17 and 20 fairly easily. So we've got 17 here that is permissive. So I was able to turn on permissive just for these tests. So you can go back to permissive very easily. It's just very hard to go from permissive to permissive minus. So this has taken about 13-ish minutes. On my own PC, it takes more like 6 or 7 hours. So beefy machine here. Now, whenever we turn on permissive minus, that goes down to about 12 minutes 46. This is outside of the range of noise, in my opinion. This is definitely something that has improved compilation time for us, which is pretty nice. Now for enabling 20, largely the same. I did do more timings, and it stayed about the same. And this makes sense because we're not using any 20 features just yet. Whenever I was doing these profiling, this profiling, so we're not paying for what we're not using at this point. So that makes sense. Okay, so what did we achieve then? Well, Sea of Thieves is now even more cross-platform. Before, yes, we were kind of cross-platform. We were on Xbox, we were on PC, but we were only in one compiler. But now, I think it's fair to say we are properly compiling for multiple compilers and multiple platforms. Good. And we have faster debug builds. So we've got copy elision no matter what debug level that you're on. So good. And as I said, C++20 showed up a lot of things for us. We were able to fix test suite error reporting with pretty printing objects. That was a great thing. And improved error detection. So it found a load of things that we're doing wrong that we'll have to come back to later. And of course, we've got some great new features, right? We're improving our developer experience just by including all these nice new features. And they love them. So as an example here, Sam is our current engine team intern. And Sam likes to blog about everything he does, which makes it very easy to quote mine him. So this is one of the quotes. I just tried to use designated initializers, but then I realized I was on Sea of Thieves. So he had been working on Everwild, and then he went back to Sea of Thieves and was a bit annoyed. So he was very much looking for 20. And then as soon as I submitted the switch for C++20, he was on it. He already had concepts going for unit testing, which was great. And it wasn't just Sam. Even our stand-up on Monday, people were talking about, oh, I put in concepts to this change list and I made things much nicer, much cleaner. So people are already using the nice new features. Okay, so I'm going to end with some takeaways. I'm going to say, upgrading is worth a try. So if you're in the position of you're on 14 or 17 and you've been wanting to do this, but you can't quite get around to it, I think it's worth a try. It really improves your code, especially going to 20. There's a lot of things that the compiler will point out to you without having to run any static analysis. So yeah, newer standards improve code quality. This was quite obvious, especially going from 17 to 20. And I learned a lot. I expected to learn a lot, and boy, did I, which is why I'm here, really. I wanted to share it all with you. And I'll just harp on this one last time. Automated tests are extremely helpful. This whole thing would have been a lot more risky, and I bet you I would have caused a lot more aggravation for like delivering and producing builds if we didn't have automated tests backing a lot of this. So tests are a necessity. Please write them. And build times don't get worse, right? Unless you're using the new features, you're not going to get anything that's going to change. You're just going to get nice new features, and your build times are not going to get any worse. Great. So future work then. I want to remove more platform PS5. There are still a few places which could be removed, so I want to remove all of that tech debt. Yeah. So I want to remove all of that. There's still some places that have it where it shouldn't. Obviously, there's places that are PS5 specific that should be PS5 specific, but there's a lot of cases where it's not. I want to go around and I want to enable warnings as errors. So if I rebuild Sea of Thieves now, I'm getting about 15 warnings still. I want to fix those. I want to enable warnings as errors, close that door behind, and then start re-enabling warnings that we have previously disabled in the past for expediency's sake. And then once all of that nice stuff's done, we can start thinking about the future. So C++23 and beyond. On my tag, I have, give me reflection, please. I have a lot of thoughts around reflection about how it can improve our code quality. So yeah, I really want to move Sea of Thieves up to there. And I don't see Sea of Thieves ending anytime soon, so we want to keep up with the standard as we go. And that's it. Yeah.